Hey, I'm Jensen, and welcome to day 1 of Functional Java for Robotics, where we will learn to code FTC robots in Java, all for free online using the Virtual Robot Simulator.
So, let's code Java. Firstly, we're going to learn why Java. Why is Java an important programming language to learn? Then we're going to explore setting up our virtual robot simulator coding environment and doing some basic experimentation. After that, we're going to learn how to code basic movement commands for our robot. And finally, we're going to do an epic challenge with everything we've learned. So firstly, why Java? Java is very versatile. It can be used for data science, machine learning, app development, and even web development. It has libraries for many different purposes, and most importantly, it can be used to program robots. And it's used in almost every industry. Next, exploration. We're going to set up the virtual robot simulator. So to set it up, we're going to go to this link right here. Now, if you're watching this on a YouTube video, the link will be in the description. If you're on my website, it'll just be under the video where the other text is. So just click on the link, and it'll take you here. Then we're going to hover over programming and hit play. Now, we're going to select on.bot Java. As you can see, there's options for blocks and .bot Java. If you're new to programming, I recommend you go with the blocks, and you can learn how to program these robots here using block-based code. But we're going to be learning text-based Java, so we're going to go to this side. So what's really cool with the virtual robot simulator is we're going to put code here, and we'll actually run it to make this robot do different tasks. So first, let's do some experimentation. I created some code here at this link. It'll be in the same spot as you found the virtual robot simulator link, in the description or under the website. But you're going to go to it and copy and paste this code, Control A, Control C, into the environment. So Control A, backspace, and then you're going to copy that code in. So I've just copied the code from the Google document at this link into this coding environment. So let's go quickly over what this code kind of basically is. So the code you're going to want to edit in this experiment, which we'll go over in a second, is here. So when you run your code, this is the blocks that are actually running. All of this is setup blocks that we'll go over in the future when we add sensors and new motors, but you don't have to worry about any of this. You want to go in the part that says if op mode is active, because that's meaning if our program is running, what to do. As you can see, it even has a nice little comment, put run blocks here to make it clearer. So anything that you want to happen when you run your robot is going to be down here. So to run your robot, you have to hit initialize program, and that sets everything up on the field, and then start program. And as you can see, our robot moves. Pretty exciting. To do that again, you want to hit reset field, initialize program, start program. You can also stop the program midway if you really want, but then you just reset field and you can run it as many times as you want. But what we're going to do, it's a pretty awesome experiment. So I want you to pause the video here and try doing a bit of experimentation. I want you to try changing the numbers in the front left and front right .setPower statements from 1.0 to 0.5 and observe what happens. And try changing the sleep statement underneath to different values and observe what happens. So what do these changes cause to happen, and why do you think these changes impact the code in this specific way? As you can see here, I have a bit of an example of me doing some of this experimentation. So pause the video here and work this out for a bit. Make sure to do all these changes, see what happens, and try to understand why this might be the case, and then we'll go over it. Hopefully you did that, and great work if you did. So, our next thing will be learning exactly how movement commands work in the virtual robot simulator and for First Tech Challenge robots in general, which the simulator is simulating. So, with movement commands, you can only start and stop motors in this environment and with First Tech Challenge robots in general. You can't tell a motor to move a certain distance in a movement command until we cover more advanced code in the future. So for a motor to move, you must tell it to start moving, wait for a certain amount of time, and then tell it to stop. You can't tell it to go for like 5 rotations around a motor. You can only tell it to just start, wait for a time period, and stop the motor. The default virtual robot simulator robot has 2 motors on the drivetrain that each control 2 wheels. The left motor controls the left 2 wheels, and the right motor controls the right 2 wheels. So to make our robot move, we must turn on the left and right motor, wait, and then turn them off. So these left and right motors all together control all 4 wheels on the robot. So since we can't have each motor just go forward for like 2 rotations to make the robot move an exact distance, we have to put both of these motors on, wait a certain period of time while they're still on, and then turn both the motors off. And that's how movement works with robots. So there's 3 parts to motor movement. Part 1, you have to set the power to something. So you set the power for motors causing them to move. The power values can range from 0 to 1.0, which changes the speed at which the motor moves. If I set the motor to have a speed of 1.0 here instead of 0.5, the robot would move a lot faster. Then we wait 12.25 seconds in this second step. The sleep statement uses milliseconds, so sleep 1000 actually means to wait just 1 second. What do you mean by sleep? Well, sleep actually is having the robot wait and not do anything. So these motors are still going to have a power that's on. They're active. These motors are moving, but instead of shutting them off immediately like we do down here, the robot waits. So for this whole 12.25 seconds, the robot is moving forward, as both of these guys have a nice positive power. And then at the end, we're going to stop the drive motors by setting their power to 0. So some of the experimentation we were doing, like by setting these two motors to power 1.0, was making the robot move faster. What's also cool is this makes the robot move farther. As it's moving for a certain amount of time, if the robot's moving faster for the same time period than before, it's going to move farther. So if I made this 0.25, the robot moves slower, and since it's only going for 12.25 seconds and it's going slower now, it's going to move less far. Now let's imagine I keep the speed at 0.5 and I change this value. What if I changed it to just 1000? Well, then the robot's only going to be moving for 1 second, which is a lot shorter, so the robot's going to move a lot less. And if I made this a really high value like 25,000, then the robot's going to be moving for 25 seconds going forward. So then the robot's going to keep going. And down here, we set both powers to 0 to stop the robot from moving. As when you have these drive motors making the robot move forward, and you set their power to 0, the robot stops. So this is the basic structure you're going to use for every movement you have your robot do. But what if you want to turn? That's just covered how to go forward. Well, when both wheels move forward, the robot would move forward. When both wheels move backward, the robot moves backwards. When the left wheel moves backward and the right wheel moves forward, the robot turns left. And when the left wheel moves forward and the right wheel moves backwards, the robot turns right. How I like to imagine is I have my hands be the wheels, and if they're both moving forward, the robot's moving forward. If they're both moving backward, the robot's moving backward. But if the left wheel moves forward and the right wheel moves backward, that means the robot's turning this way. And vice versa. If the right wheel moves forward and the left wheel moves backward, the robot's turning left. But how do we program that? Well, if you want a wheel to move backwards, you can just set its power to a negative value. So if I have this right wheel going forward at 0.5 power and this wheel going backwards at negative 0.5, then the robot's going to be turning. And I can do the same thing with the sleep statement to have these motors active for a while, and then eventually setting their powers to 0. So I have some example on screen of doing different things. So here, the robot's going to be moving forwards at 0.5 power for 12.25 seconds like you saw before. But here instead, the robot's going to be turning left at 1.0 power, meaning the motors have more power, so the robot's actually moving faster, each of those wheels. And the power is going to be for 2 seconds. So it's going to be a left turn for 2 seconds at 1.0 power. And here we're actually moving backwards at 0.7 power for 1 second, because both these powers are negative, so the motors are moving backwards. And therefore the robot, since both of these motors are negative and going backwards, is moving backwards for 1 second because of this weight here. So, compound movements. To make your robot go forward and then turn or move another way, you simply put the code for each type of movement in the order you want them to be. Make sure to put a sleep statement for however long you want each movement to be between movements. In this example code, the robot should move forward at 0.5 power for 3 seconds and then turn right at 0.5 power for 3 seconds. So you can see what the code is causing right here. It's causing the robot to go forward and spin. So here, both motors are positive power 0.5 for 3 seconds. So the robot's going to be moving forward for 3 seconds, just like it is here. Then the left wheel is going backwards. So that side's going backwards. And the right side here, the right wheels, is going forward. So this makes the robot actually spin here. And it's spinning to the left because the left side's going backward and the right side's going forward. And if you ever are not sure, just test it out. Have one side go positive, one side go negative. If it turns the way you want, great. If it doesn't turn the way you want, mix it up, change the values, and then it'll work. And finally here, we're stopping and just waiting a second, just having the robot stand still here because both powers are at 0. So as you can see here, these make it go forward, this makes it turn, and here it stops. So, time for your challenge. So my challenge for you is to make a square. You're going to use the movement commands you have your robot move forward and then make a square. Consider adjusting your power or sleep times to have the robot move and turn the correct amount. On here you can see a robot completing the challenge. It doesn't have to be a perfect square, it's okay, but just generally you want the movements down. So we see I go forward, I turn, and I make a square. So you guys, I hope you pause the video here and work through it. It's totally cool if you get stuck because when you guys come back, I'm going to go over the solution and then you can follow along with me and get it working yourself. If you guys want to challenge yourself even more after this class, you could try to make your robot do some other cool shapes like a figure 8, a triangle, whatever you guys can think of to test your skills. So take a break here, pause the video, and try this challenge out. And then come back and I'll go over it if anyone's stuck or wants to see me go through it. Great work, guys. Let's go over how to make a square. So I'm going to go to the simulator and do it myself so we can really follow along. So I have the initial code I gave you to experiment with here. If I initialize the program, start the program, the robot moves forward. So, well, that's a good first step. The robot was supposed to move forward. But I'm going to make it move forward a little bit further so I don't interfere with all these rings and stuff when I turn. But it's totally cool if you don't do that. So let's make this. So right now it's 2.25. Let's make it 2.5 seconds forward. And as you can see, I'm changing the code down here because this is where the code that actually runs when you hit start is. This if op mode is active is saying, if I'm running the program, what am I going to do? So all of this is just setting up the program, setting up where the motors are, which we'll go over after, and how to set up sensors and everything here. This is the code that actually runs. So now that I made that a little bit greater, the robot's going to go further forward. Great. Then up here, I'm going to want to turn. So I'm going to copy and paste because I don't want to have to write out front left.setPower, front right.setPower a bunch of times. So then copy and paste. And now we want it to turn. So we want the left wheel to be moving forward. And I'm going to make it a little bit slower. And we're going to have the right side going backward. This will make it turn to the right like I want it to. I put the power a little bit slower so I can adjust this turn to try to make it more of a 90-degree turn. So let's see what this looks like with just going for half a second on the turn. Initialize, start. Okay, that looks pretty good. So we're going to stick with that. So after it turns, we want it to go forward so it can start to make a square. So I'm going to make this positive now. And we'll just keep it for a half a second. Feel free if you finish early or you already have succeeded in this, experiment with changing these values, make a different square, make a huge square, make a tiny square, make the robot move really fast through a square, whatever you want to do. So here we go, we turn, and we went forward a bit. Didn't really go forward too much though, I couldn't really see that. We're going to go a bit further. And I still think the robot's going to hit these rings when it comes back around. So I'm going to make the robot, when it goes forward at the start, which is with these blocks here, go forward quite a bit further. So let's make it a whole second further. So I went from 2,500 milliseconds to 3,500 milliseconds. And since 1,000 milliseconds is a second, the robot's going forward a whole second further. So initialize, start. There we go. Robot turns 90 degrees, forward, great. So to make a square, we turn 90, we went forward. We want to do that for every side of the square. So I'm going to copy and paste this once, make sure it's looking good, and then we'll copy and paste it again. So this is the robot. Here's where the robot goes forward at the start. Here's where the robot actually goes forward. Here's where the robot goes forward at the start. Here's where it turns and then goes forward. So we're going to want it to make more sides of this square. So we're going to copy this, go down here. There we go. Now it's going to make another side to the square. Initialize, start program. So we turn and go forward here. Then we turn and go forward here. So as you can see, that's not quite 90 degrees. I'm not very happy with that. Look at that. It's all kind of tilted. So instead of 500 milliseconds, we're going to go 510 milliseconds here. And we're going to run it again. So I initialize, I start. There we go. That's a lot better. And then well, we turned and went forward. We turned and went forward. But we have to turn again and again. We have to make 2 more sides to this. So I'm going to copy paste this code here. So this is the code for turning and going forward twice because it turns and go forwards, turns and go forward. We have to do that 2 more times to make a full square. In the future, we'll go over something called loops that can really help simplify this code. But for now, this is what we're going to do. We're just going to copy it again. So this should make all 4 sides to the square. Here's side 1, side 2, side 3, side 4. So we're going to, if you want, you can reset the field. Initialize program, start program. And there we go, we got a square. So if you have extra time, you can feel free to experiment with some of these values, change it up, try to make cool other shapes like an octagon if you want, or a triangle, or a figure 8, whatever you want to do. Okay, great. Now that we've finished making a square, we have another challenge called Push the Rings. So if you understand everything we did in the last challenge, then we can move on to this one. So what you're going to do is use what you learned in the last challenge to push the orange rings to one of the red squares on the other side of the field. Now, sometimes the rings may disappear. If you do this, hit reset field and it'll make these rings come back so you can push them. And you may need to consider turns where one wheel has power and the other has no power, so the robot turns with a different axes of rotation. What this means is if both wheels are turning, the robot's turning about its center, but if only one wheel's turning and the other wheel has no power, so it's stopped, the robot's turning just about that wheel, and you might need some of those turns to be able to successfully push this ring into the square, or you may want to consider using them. So here'd be an example of one of these turns. Feel free to write this down in your code and see what happens. You see what more of what I mean. So this is what you want the robot to do. Pause the video and go work out this challenge. And when you finish or get stuck, come back and I'll work through it with you. Here you go. So see you soon. Welcome back. Okay, let's go through how to solve this challenge. So we're going to go to the programming here. And this is all the code from the square. Let's just get rid of all this. We don't need to make a square anymore. We still want this stop at the end, though, because we don't want the robot to move forever. So first things first, we're going to go forward, although probably a lot less than this. We're going to want to go forward a little bit. So let's reset the field. As you can see, oh no, there's no rings. We'll reset the field again. Still no rings. Yay, there's rings. So initialize the program, start the program. So it seems a little bit too far. I just want to go forward a little bit so when I turn, I don't hit that wall. So then we're going to turn. I'm going to stick to 0.5 power just because it's easier to adjust times and whatnot for. And we'll do it for 510 milliseconds. And, well, the left side would have to go forward. The right side would have to go backward to make a turn to the right. So initialize, start. There we go. It seems like a little bit too much turn, so 505. Then we're going to go forward a bit. And I'm just guesstimating here. As you program robots in the real world, or just in the simulator, you often just have to run it again, change values, adjust. So initialize program. Yay, there's rings, start program. So it's looking pretty good. We want to go quite a bit further, though. And we're kind of hitting this wobble goal. Or this is what it's called. It's called a wobble goal, these guys. And I don't really want to hit them, because that might impact our robot in the future. So we're going to go 180 forward. We go less forward at the start, so when we turn, we hopefully won't be hitting this guy. Run it again. Great. Now I'm going to want to go a lot further forward because we want to be over here. So 1,000. 2,000. So another second. Cool. It's a little bit too far. About 1.5 seconds. Cool. So now we're going to turn back this way because I want to get past these red wobble goals too. So I'm going to copy this, and this would make it go to the right. We want it to turn left, so we'll just change these powers here. Cool. So now I wanted the robot to be a little bit further this way, so we're going to make this guy a bit greater. Initialize start. Cool. Then we're going to go forward, turn again, and then try to do a one-wheel turn to get us at the perfect angle to push these rings into that square. So let's go forward again. You might notice I always have my turns at a slower speed than the forwards. That's just because it's a lot easier to control the exact value of the turn if the wheels are slower. Because, if you're going at double the speed, every millisecond is double the distance the robot's moving. So you have to adjust things by even smaller numbers. Well, here I have double, each millisecond is only half the distance the robot's moving now. So if I were to decrease it by 10 milliseconds here, it'd be it changes the movement more fine-tuned than with this, where the robot's moving further for each millisecond. So there we go. We're going to go forward now. Probably not this much, though. Let's see what happens. Cool. Cool. Now we're going to turn to the side again. We want it to be to the right, which this turn I believe was. If not, I'll just switch the values. Okay, so it's a little bit not far enough, so we're going to go a bit further forward before that turn. 200 milliseconds. And oh no, there's no rings. That's all right. When I reset the field, they'll hopefully appear again. A little bit further forward though. 200 milliseconds further. Yay, there's rings again. Okay. So coding is just a lot of experimentation. You run it, see what happens, and adjust it accordingly. So we're going to go forward and approach this ring now. So let's copy this forward statement. We don't want to go forward too far though. So I'm going to make it like 900 milliseconds. Initialize, start. Great. And now I'm going to have just this side of the robot turn to push this ring. Because if I had both of the wheels turn, the ring might slide down the side of the robot, which we don't want. If I get just this side of the robot to move and this side stays still, hopefully the ring will move along with the robot and I can push it in an angle that I need to approach this section. So therefore I want only the right wheel here to move and the left wheel is just going to stay still. So let me show you how to do that. Oh no, I forgot to go F. There we go. So the front left is going to be moving nowhere. So we're going to set its power to 0. And the front right will have a positive power. So we want the right side of the robot to move this way. And the left side is just not going to move. And hopefully that'll move with the ring. And let's see what happens. Let's go like 200 milliseconds and see where we get. Initialize, start. Okay, as you can see, our robot's not quite far enough forward to be moving that correctly. So let's make sure we move a little bit further back when we go forward, all the way back there. So, initialize, start. Well, now let's move too far forward, so a little bit less. And there's no rings. Stop, initialize, start. Cool. So I'm going to want to move a little bit further in my turn. So like, there we go. Double the turn. Okay, that's looking pretty good. I want to be a little bit less far forward when I'm doing that though. So let's go. And then we're going to move forward, hopefully pushing the rings into the square. Initialize, start. Okay, great. I think we need to turn a little bit more to get that ring in there. So like, there we go, and go a bit further forward. So I'm just adjusting these time values so the robot moves longer and goes further, therefore. And we push the ring right into the square. We did it. Let's go. So if you guys just follow along, you can hopefully succeed in this challenge. If you're stuck on anything, feel free to contact me if you can't figure it out by going through and just making sure all your code looks correct. If you guys want an extra challenge, you could try to move this ring into one of these squares or move the ring into a different square altogether to get more practice with this kind of coding. And that was our final challenge of the day. I hope you had a great class, folks. I hope you understood everything. If not, feel free to contact me or just say it in the comments or contact me through my website, and I will definitely help you out. Thank you, and I hope you guys can come to the next class. Have a great day.